Welcome back to OCR MEI Further Mathematics B. Today we're doing chapter 3.10, Point to Line and Plane. So the scenario is from a point to a plane or from a point to a line. For the point to the plane, it's kind of similar to last chapter when we talked about from a line, the intersection between a line and a plane. Except this time we are going to use the dot product to find the perpendicular distance from the plane to the point. For the point line, it requires you to use the vector area equation with the cross product, which I'm going to talk through during the example section. Example number 1 is a line to a point. So it's tricky. I did tell you that you need to use vector area for this. So let's have a look. So let's do it on a graphical kind of sense. You've got a line with a directional vector -1, 2, 2, and you've got a point A, where A is 2, 1, and 3. So with that said, if we take the direction with a unit distance, say this will be d hat, you'll go up to a point, arbitrary point x. That's actually a bad notation because we're going to use x in a bit. Let's say it's a point w, why not? So we've got point A to point W with a unit direction d. So let's first find vector d hat. So d hat is the directional vector d divided by its modulus. So we've got -1, 2, 2, all divided by a unit which is a 1 squared, which is the square root of every component squared. So -1 squared is +1, 2 squared is 4, 2 squared is 4, that's sum to 9, and take the square root of it, it's just 1/3. So we've got this as our d hat. And we have a point 2, 1, 1 over here. So if we take the difference between A and the point, which will give us, let's say direction doesn't really matter in this case, so let's take the point, let's take A take the point, which will give me, let's see, A take the point is this direction, and this will be 2, 1, 3 take 2, 1, 1, give us 0, 0, 2 as our difference. This will be the vector. With that said, if we do the classic dot product, cross product rather, we will find the area of this triangle, shaded in red. This area A is equal to 0, 0, 2 cross d hat or divide by 2, and this is just a definition of a cross product area. So take the modulus of the cross product, divide by half, gives you the area of the triangle in factor form. So with this, if we take the modulus, we get the magnitude of the area, and with that we can use the typical equation for the area of a triangle, which is base, I'll denote blue, base times height perpendicular divided by 2. So we can also say that area is equal to base times height. Actually, this is a really bad notation. Base times height, they're not factors, they're scalars, remember this. So the distance b is the magnitude of d hat in this case, which is also 1, because by definition a unit factor have length 1. So you take that into account, and so area is actually h. So this will be the height, or the minimum distance between the point and the line. And so height equals to this cross d hat all over 2. So let's find that. Actually, this is bh a half. don't forget this, half base times height is triangle, which means that this is 2 h's, or actually no, my bad, half a h. So with that, multiply both sides by 2, we cancel the denominator. We've got h is just the cross product between these 002 and this value. So let's do the cross product. Apologies for my throat. So let's take 002 cross of minus a third, 2/3, and 2/3. Take the determinant of this matrix, gives us, for I we have 0 subtract by 4 on 3. For j we have 0 plus 2/3, but all negative, so it's minus 2/3. And for k, 0, 0 is just 0. So I've got this, and now remember to take the modulus of this factor, which is just the big square root of this is 16 on 9, this is 4 on 9, add them together, give us root 20 on 3, and that is the separation between the line and the point. So now we've done a point and a line, we can do a point and a plane. So to find that, we can just use the knowledge we had before from last chapter. So let's first do it graphically again. Hypothesize a plane with a unit normal n hat, and we can state a point 312, in this case I'll call it P, and we need to find a point on the plane. Let's call that A as usual. And normally what we would do is to find the distance between the A and P as a position factor as usual. direction doesn't really matter because we're going to take the modulus anyway. With that, we want to find a unit normal such that it points directly on the point, and there will be a unit normal on the plane anywhere that does that, so we don't actually need to know where this point lies. So with this, we have made a triangle, a right angle triangle, and to find out what the separation is, we just need to do as we have done before, a cosine angle kind of rule, which means that it is a dot product. So we can try dotting p take a with n hat as our separation, and for this particular plane, the normal factor is 1 minus 1 plus 1, and the unit normal is 1 minus 1, 1, or on root 3, because 1 squared plus minus 1 squared plus 1 squared is just 3. With that, we can now find PA or AP. So let's find a point A. Because it's not given to us, we need to kind of hypothesize one. We can do, there are multiple ways of doing that, one of which that is obvious is to put x is 0, y is 0, and z is 0. For the purpose of demonstration, I'm going to use another set of values. You can try the 0001 on parallel to me just to check if the value works, but they should give the same result anyway. So let's use 1, 2, and 1 so that 1 take 2 plus 1 equals 0. So we have 1, 2, and 1 as our point. And now we can take the 1, 2, 1 away from 3, 1, 2 to get 2, minus 1, and 1 as our separation. So with this separation, we can apply the dot product. So we dot this value with 2 minus 1, 1. That should give me 2 on root 3, plus 1 on root 3, plus 1 on root 3. That gives me 5 on root 3. 2, 1, 1, 2. Yeah, that should be, actually no, this is a 2 plus 1 plus 1, it's actually 4, I cannot add today. So it's a 4 on root 3. Apologize for the error, but yeah, so this will be the separation between the point and the plane. So my tip for this chapter would just be try to understand how the geometry work. When necessary, draw triangles and try to visualize how the dot product and cross product actually functions. And when in doubt, write down dot and cross product in the trigonometry form, which involves the sine and the cosine form, which this will help you a lot when dealing with whether you should do a sine or to do a cross product or a dot product. Make sure that don't forget to use the unit factor because it helps a lot. Once again, it's question time. So I have formulated 2 questions for you today. Just basically find the minimum separation between these 2 objects. And as usual, you have 5 seconds to pause the video before I show you the answer. and make sure you try them out because practice is important. So without further to say, I'm gonna give you the answer in 5, 4, 3, 2, 1. So the answer is shown here, root 14 on 3 and 15 on root 14. Yeah, it's actually not that complicated, and this entire series on factors really comes down to a lot of practice. And when you understand what a dot product actually is and what a cross product really does on the geometry front, then you would be able to apply them a lot more casually, just like you can do normal multiplication on scalar numbers. But anyway, this will be the last video of chapter 3, and next up we're gonna do a bit of matrices. If you have any questions regarding factors, leave it in the comment section below, and I will see you on my next one.